Hello! Welcome to my channel, Inside Information. Human Mission to the Moon. A Journey Beyond Earth. Introduction. The human mission to the Moon stands as one of humanity's most extraordinary achievements. From the first landing in 1969 to modern plans for lunar bases, humanity's fascination with the Moon has inspired technological innovation, exploration, and ambition. This article explores the history, achievements, scientific insights, and future plans related to the human mission to the Moon. 1. Historical background of lunar exploration. The journey to the Moon began during the intense rivalry of the Cold War between the United States and the Soviet Union. Known as the space race, this era saw each superpower strive to assert technological dominance. The Soviet Union initially took the lead with several pioneering space achievements, including sending the first human, Yuri Gagarin, into space in 1961. However, in 1961, President John F. Kennedy announced a daring objective: to land a man on the Moon and return him safely to Earth before the end of the decade. 2. The Apollo program, reaching the Moon. The U.S. Space Agency, NASA, launched the Apollo program in response to Kennedy's goal. This program involved extensive research, numerous missions, and the construction of the Saturn V rocket, the largest rocket ever built. Apollo 11, commanded by Neil Armstrong, was the first successful mission to land on the Moon. On July 20, 1969, Armstrong famously took humanity's first steps on another celestial body, uttering the words, "That's one small step for man, one giant leap for mankind." In total, 6 Apollo missions, 11, 12, 14, 15, 16, and 17, successfully landed on the Moon between 1969 and 1972. These missions collected lunar samples, deployed scientific instruments, and provided a wealth of data on the Moon's geology and environment. 3. Scientific discoveries from the Moon landings. The Apollo missions yielded crucial scientific discoveries that changed our understanding of the Moon and the broader solar system. Key insights include geological knowledge. The Moon's surface is covered with regolith, a layer of loose rock and dust, indicating the effects of billions of years of asteroid impacts. Formation theory. Samples showed that the Moon is primarily composed of materials similar to Earth's mantle, supporting the giant impact hypothesis, which suggests that the Moon formed from a massive collision between Earth and a Mars-sized body. Volcanic activity. Analysis of rocks indicated volcanic activity on the Moon billions of years ago, revealing its early dynamism. Potential resources. The discovery of elements like helium-3, which could be used in fusion energy, has spurred interest in lunar resource extraction. 4th. Technological innovations. Inspired by Moon missions, the Apollo program led to numerous technological advancements, including miniaturized electronics. The Apollo guidance computer was one of the earliest computers small enough to be used in space, leading to developments in computing. Materials, science. Development of materials like Teflon and heat-resistant fabrics originated from the space program. Medical technology. Advances in remote monitoring, telemetry, and imaging benefited healthcare. Environmental technology. NASA's innovations contributed to water purification and waste management systems. The Moon and its influence on culture and imagination. The Moon has been a central symbol in myths, literature, and art throughout history. In the modern era, images of astronauts walking on the lunar surface became iconic, symbolizing human ambition and exploration. The Earthrise photo taken by Apollo 8 astronauts, showing Earth from lunar orbit, shifted humanity's perception of our planet, inspiring environmental movements, and the concept of Spaceship Earth. 6. The renewed interest in moon exploration. After the Apollo missions, lunar exploration slowed down due to budget cuts and shifts in political priorities. However, interest in the moon has revived in recent years. The reasons include scientific curiosity. Unanswered questions about the moon's history and composition drive further exploration. Resource extraction. The moon contains rare resources such as helium-3 and possibly water ice at the poles, which could support long-term lunar bases. International competition and cooperation. New space players, including China and private companies, are developing their lunar missions. 7. The Artemis program, NASA's vision for a sustainable lunar presence. In 2020, NASA initiated the Artemis program, a new mission series aiming to return humans to the moon. Named after the twin sister of Apollo, Artemis reflects a vision for sustainable exploration and includes Artemis I, an uncrewed test flight to orbit the moon and test the Space Launch System, SLS, and Orion spacecraft, which was launched in 2022. Artemis II, scheduled to be the first crewed mission to orbit the moon in over 50 years, set to launch around 2024. Artemis III, planned for 2025, it will attempt to land astronauts near the moon's south pole, potentially paving the way for a sustained presence. The Artemis program aims to establish the Lunar Gateway, an orbiting space station around the moon, which will serve as a staging area for lunar exploration and possibly for future missions to Mars. 8. International contributions to lunar exploration. Global space agencies like ESA, European Space Agency, Roscosmos, Russian Space Agency, CNSA, China National Space Administration, and JAXA, Japan Aerospace Exploration Agency, have expressed interest in lunar missions. China has made notable progress with the Chang'e program, and in 2020, Chang'e 5 successfully returned lunar soil samples. These missions demonstrate international cooperation and competition in space, with partnerships potentially enhancing the scope and scale of lunar exploration. 9. Private sector and lunar exploration. The private sector, especially companies like SpaceX and Blue Origin, is crucial to the future of lunar exploration. SpaceX's Starship, designed for human transport to Mars, could revolutionize lunar missions with its reusability and payload capacity. Blue Origin is developing its lunar lander, Blue Moon, and has partnered with NASA on the Human Landing System (HLS) program. The private sector's involvement promises reduced costs, faster innovation, and expanded mission capabilities. 10. Long-term vision, a moon colony. Establishing a permanent moon base has been a long-term goal for scientists and futurists. A lunar base could serve as a hub for scientific research, resource extraction, and a launch pad for Mars missions. Challenges include radiation exposure. The moon lacks an atmosphere and magnetic field, exposing inhabitants to harmful cosmic radiation. Sustainability. The costs of transporting supplies are high, so sustainable resource use and in-situ resource utilization, ISRU, are essential. Psychological factors, long-term isolation, and low gravity can affect mental and physical health, requiring innovative solutions for habitability. 11. The future of human missions to the moon. The future of lunar exploration holds immense promise. Advancements in robotics, AI, and propulsion technology could make the moon a thriving center for science and industry. Potential breakthroughs include robotic assistance. Robots could assist astronauts in construction, mining, and research, making lunar operations safer and more efficient. Advanced propulsion. Improved propulsion technology could reduce travel time and cost, making lunar missions more feasible. Lunar tourism. If technology and infrastructure evolve, lunar tourism could become a reality, providing a new perspective of Earth. Conclusion. The human mission to the Moon represents one of the greatest achievements in history, exemplifying the power of human curiosity, cooperation, and ingenuity. As we prepare for new lunar expeditions, the Moon remains a symbol of our quest to explore, innovate, and understand. The next decades may see humanity not only return to the Moon, but make it a stepping stone for exploring our solar system and beyond.